Hi there. So here's some hints and some helps to get you started on the homework. Now, I'm not going to tell you all the answers because you have unlimited attempts to try. So hopefully this is just to get you started in case you get stuck or you're just not quite sure now, what to begin on. So standard position, if you remember from the notes, means that it starts on the x positive axis, so here, here, or here, and 110 degrees, because it's positive, that means it's going counterclockwise. So which one of these is 110 degrees? This one's not too tough because you should all be familiar that all the way around a circle is 360 degrees. So halfway would be 180, a fourth of the way would be 90. Now, number 2 is a little bit different because it's negative 900. 900 degrees in standard position. So this one, you're going to start on the x positive axis and look at which one is negative 900 degrees. So probably the first thing that I would do is recognize I'm going to be going counterclockwise. And I'm going to just look at this and say, well, it's at negative 900. One complete revolution around would be adding 360 to that. So a negative 900 plus 360 is negative 540. And then I'm going to add another 360 to that, and I get 180. So now that just reduces it to going around 2 times plus another 180, which would be another half circle. So you should be able to find the answer with that information. So number 3, we have to find a positive angle and a negative angle that's coterminal with 70 degrees. So if you remember, the word coterminal means that it's beginning and end point, basically the same thing. But if you think about this, I'm just going to quickly draw what 70 degrees would look like. So it would start at the x positive angle, and 70 degrees is it's 20 degrees less than a 90, so it would be still in the first quadrant. So it would just be that angle right there. And then one positive angle that would be coterminal would be the same one if you add another 360 to that. Or a negative angle, you could think of it as if you start here at the x positive and go around this way. So one possible positive angle is if you add 360 to this angle here, that would be a positive one. Or if you do the negative one, go around this way, then that would be a negative angle. So hopefully you can figure it out from there. Same thing for number 4. The negative 125 degree angle would start here on the x positive axis. Only negative 125, well, negative 90 would be to right here, so it's like 35 more than that. So it's somewhere over in the third quadrant over here. So it's that angle right there. So a positive one is if you could think, well, it's going to start here and end up that way. And a really easy way to find the positive angle is to take 360 and minus 125. And then another negative angle, you would have to think, okay, I'm going negative direction. So I'm going to start here and I'm going to go all the way around one time and then the same angle again. So this time we would add another negative 360 degrees to get that negative angle. Okay, so hopefully you remember from the notes how to convert from degrees to radians. And I just usually think to remind myself that radians is going to be in pi. So I'm going to multiply by pi and then divide by 180 degrees. So that's the formula to find the radian measure that's equal to 40 degrees. And converting from degrees to radians, again, you're just going to multiply by pi and divide by 180 degrees. This time your answer is going to be a negative. And we always remember that when we are finding radians, we are not going to the decimals. We're going to make a fraction and just reduce it. So I'm going to take this a step further and help you out with this. Because when you multiply these together, you'd get 260 pi over 180. And then you just need to reduce the 260 and the 180. Well, I can divide a 10 off of both, and 26 and 18 are both even, so I could cut those in half and I'd get 13 pi over 9, but it is negative. Converting from radians to degrees is just the opposite. And one way that I think about it is there's a pi in the equation already, so I have to divide by a pi, and then I want to get it to degrees, so I multiply by 180. So then when you're multiplying these two together, if you write them together, then when you multiply, the pi's cancel out, and you just get 180 divided by 9, and that's your answer. Same thing here. This one is negative 5 radians. Now, there's not a pi in the answer or the problem that we're working for, but it does tell us that it is radians. And also, it doesn't have a degree sign. So that's another way for you to know that it is in radians already. So we want to then divide by pi and multiply by 180. And this time you're going to get a decimal answer, but that's okay because it says round your answer to the nearest tenth. So you just grab a calculator, negative 5 times 180 divided by pi. Number 9 is interesting. You've got to think about it for a minute. So let's talk about this. The terminal side of an angle in standard position rotates 1/6 of a revolution counterclockwise from the positive x-axis. Describe how to find the measure of the angle in both degree and radian measures. So first they're asking a full revolution is how many degrees or how many radians. And you should remember a full revolution, that's just what you're used to, is 360 degrees. And radians, if you can, this is a really important thing to remember. A complete circle for radians is always 2 pi. So if the terminal side rotates 1/6 of a revolution from the positive x-axis, we multiply by 1/6 to get the degree of. So if you take 360 and multiply by 1/6, that tells you what the angle degree would be. Or you would divide by 6 to find the number or the radians. So you can take 2 pi, divide it by 6. That will tell you the radians of the angle. And the last one is a modeling problem. And this is really interesting because this is where all of this comes into play, why we would need to know lengths of arc or areas. So, and this is just a simple example of it. So shot put, the length of the winning shot was 21.89 meters. A shot put must land within a sector having a central angle of 34.92 to be considered fair. So the angle of the shot put area would be 34.92 degrees. All right, so if the officials draw an arc across the fair landing area marking the farthest throw, find the length of the arc, round your answer to the nearest tenth. So to find the length of the arc, you're going to use the formula that's in your notes. And since we're given the angle in degrees, we're going to use the formula that is the arc length. Whoops, that should be arc length equals 2 pi r times theta over 360. So plug it into that formula and you'll be able to find the answer. Remember, the radius of this was 21.89 and the angle degree was 34.92. Then part B says that if the officials or all fair throws in the 2012 Olympics landed within a sector bounded by the arc in part A, what is the area of the sector? So this time you're going to use the formula for area of a sector, which is also in your notes, but I'll write it here just as a reminder. And since it's given in degrees, we're going to use the area formula that has degrees, which is theta over 360. You'll put in the area of the angle, or the angle right here for theta, and then pi and r squared. And r squared is given in the original problem. So you just plug those in your calculator and find the answers. All right, well, good luck. And if you have any other questions with the assignment, just be sure to email me or text or something. So good luck.